Hello students, this quick video will be an assistance to you in helping you fill in this table. I'm assuming that by now you've probably figured out how to do so. It's quite self-explanatory, but in the event that you haven't or haven't started yet, hopefully this will provide you a little bit of guidance. General terms, what I've done is I've printed out the table itself. You can do this in Excel, no problem, but I'm going to show it old school. In addition to fill out this table, you will require some kind of calculator. I'm using my tablet in this case. A scientific calculator works best if you're not doing it in Excel, that is. Course notes. I've printed out the course notes. There's lots of good information here. I viewed all the videos. And of course, you should have by now your textbook because it has exactly what you need to do for this assignment, including the tasks, what to put in the report. Lots of good stuff in there. Let's get to it. So first things first, I'm going to zoom in to give you a better view of the table itself. So the data in here, you'll notice it's not the same as the one for your lab. I just picked data from a previous lab. The first thing that we're going to do is we're going to cover the top portion of this table, starting left to right. So all of this information was provided to you. The next thing we have to do is calculate the void of solids Vs. It's shown here. It is the dry soil weight in grams divided by the specific gravity. And you notice how the specific gravity was an assumed value. So we'll do this ratio. This number divided by that number gives us. Now notice how I did not put the units after this number, nor did I put the units after any of these numbers. That's because they're provided for you. So moving on now to the right hand side, you're given the diameter, and if you remember the formula to calculate the area of a circle based on the diameter, and you work it out, 2 out of 3 times, I got this value. You were given the length, the height of the specimen, therefore you can calculate the volume. The formula is provided for you here. You multiply these values, and 3 out of 4 times, I got this number. Finally, the void ratio. The formula is provided for you here. So when I plug it out and I do it 3 out of 4 times, this void ratio is also to be repeated here in this summary table, and that's what I'm going to do right now. Which then brings us to filling in the heart and soul of this exercise, calculating the coefficient of permeability, K, which if you remember the course notes and what we discussed during the lab 2, essentially represents the speed at which water drains from this specific type of soil. Let's get to it. The coefficient of permeability, the formula for it, K, was provided for you in your course notes. It likely looks something like this. Now, based on the information that you were able to gather during your lab, a more expanded version of that formula is right here. The only difference is this is the coefficient of permeability at 20 degrees, which is the temperature at which we assumed the water was. We assumed that value again because it allowed us to get a viscosity correction factor of 1. Otherwise, we would have had to calculate what the viscosity correction factor. Remember, we discussed this in class, how if the temperature had been different, this would have been affected because water flows faster or slower. If you use this formula here, with all the data that's provided for you here, 3 out of 4 times for 1A, I obtained, with these numbers, 0.156. It turns out it's convenient to express the coefficient of permeability as a number that is 1 point something times 10 to the negative something. Let me show you exactly what I mean. This is the number that you get if you plug in the appropriate values into this formula. However, if you express it in scientific format as follows, say for 1b, it would come out to be 1.55 times 10 to the minus 2. So it's always convenient to show the coefficient of permeability as 1 point, 2 digits, times 10 to the minus, and this exponent depends on your overall number. So similarly, for 2a and 2b, based on these numbers, The values are 3 out of 4 times, 1.38 times 10 to the minus 2 here, and 1.40 times 10 to the minus 2 here. I'll show you in a moment why that's helpful. Not critical, but helpful. For 1a and 1b, we now have to calculate the average, right? We did it twice, just in case the first time we didn't do it correctly. So the average between these two numbers is, again, expressed it as 1 point and then 2 digits, 1.56 times 10 to the minus 2. Similarly, for test 2, for this example here that is not yours, it's 1.39 times 10 to the minus 2. And then I enter a line here where I ask you to calculate these values in centimeters per second. Pardon me, they're given in centimeters per second, but I'm asking you to give it in meters per second. That's simply a unit conversion issue, which I'm sure you'll have no problem with. But if you do, please come and see me and I'll help you with it. Okay, so for this number then it becomes 1.56 times 10 to the minus 4. 1.39 times 10 to the minus 4. That's great. So we've now filled out the table with all the necessary information, and that represents essentially the majority of the work associated with this lab. Now the next thing though is to put it all together. Using the course notes, you'll notice that there's a table somewhere in here looking something like this that you can actually use to identify what this soil is. Now granted, you might remember exactly what the soil was that we used for this test, but that table will assist you based on these values you got. They're actually fairly close together. If you also go to your course notes, you'll remember that you had also this table here, which has along the x-axis the hydraulic conductivity in meters per second, and along the y-axis the void ratio. You can also use this table to identify what kind of soil it is that we tested in the lab. Great. I'm sure you've already done this after having reviewed your course notes and the lab, but in any event, this concludes our quick tutorial for this lab. Good luck, and I look forward to receiving them.